And welcome to this Ladyada.
Hey everybody, and welcome to my desk. It's Sunday night. It's engineer o'clock. It's time to see what I've been hacking on.
You got some samples, and we're going to do great search, and we got to do a thing later tonight, so we're going to make this a very efficient show. So
this is going to be a breezy one, but I still have some cool stuff to show off.
Oh, we always do.
Okay, so first off, let's go to the overhead. I'm going to show off some cool samples I got. So, I just got, I got some funky, weird things. So this is, I've never actually, I've kind of heard of these. I've never seen them before. So this is a rotary encoder. So it's like clicky. And it's encoder, but it's hollow. I see people who are trying to make, rotary encoder with OLEDs in them. And it's like, how do you do that? Well, you could do it like this because the part that rotates, would be the outer ring. And then you could have electronics come through and have a display or something. So this is kind of neat. I think these are used in automobiles. Like this was sold as a replacement for a car, like a knob thing for like selecting like AC or fan. So you got this. That's one sample.
All right.
I was like showing weird stuff. Fact of the matter is, I did a lot of like parts sourcing and redesigning this week, so I didn't do a lot of new hardware. And here's another. This one is smoother. It's not as clicky, but it's also a rotary encoder. But I'm thinking of stocking these. Maybe make a breakout for them or something. Okay, and then next up, and then I got like a tall one. They're all kind of similar, but also this one's very clicky, but also rotary encoder. But then again, you can imagine the 3D print. This stays still. And then there's a 3D printed part that clamps onto here, clips onto, there's these notches, so it'll stay in place. And then above it, you can have, a thing that doesn't rotate that has a display. So, you'll probably see this soon in some known Pedro project that we come up with.
Yes.
And then I got this joystick. So, one of the things I really like the modern, Switch PSP style joysticks. But they tend to be, they're actually digital. They're not analog anymore, which is actually the right thing to do because analog potentiometers get scratchy. They get worn out from like people constantly numbing them. So if you actually went and got replacement, like I think the PSP Vita and the Switch, the potentiometers are not analog. They're digital. They use a magnetic, they use a magnet and they use like a 3D magnetic sensor to detect the motion, which means that they don't drift as much and they don't get scratchy. Because it's very hard to replace the joystick, and of course they used a ton. So what's nice about this is a potentiometer version, but it's got that nice soft rubbery feel to it, and you got the 6 pins for the two analog potentiometers. So there's some couple fun samples, mechanical samples that I got. Another thing I got that you'll see coming soon to the shop is for those who remember. We had I did this revision where all of our solderless breadboards, I really wanted like really nice ones. So I spent like months sourcing different breadboards that had clips that were really easy to plug and unplug boards from. Like they're what Phil B likes to call buttery smooth. And they also come with a metal plate, basically just upgrading, premiumizing the breadboards because, even though they were well more expensive, they were well within the price range I was comfortable selling at the same price. So all of our breadboards got updated. One of the things I always really liked was Particle had really beautiful breadboards in their kits that were like this really crisp white color, and I really liked that the ground line was black, not blue. Not that there's anything wrong with having blue, but it's black is ground, red is power. So why not? So I got samples this week of a new breadboard. You can see the color. It's much, it's hard to tell here, but it's a crisper white color. And then the power lines are, I think the printing is much clearer, and it's black on the ground line, but it also comes with a metal plate. But otherwise, it's should be compatible. Like this plugs into this if you want to extend it. And then it's still got the the buttery smooth activation for plugging stuff in and removing it. So nice. So it'll be coming soon. So I just got the samples today, and I'm going to approve them and then we can put them in the shop. So that's cool. Hold on, let me put this back. Okay. And then, last thing on my desk, the thing that I started on, but I didn't get to finish today, because I went out for a nice long walk instead, is the ESP32 ItsyBitsy. I tested it by hand. It's ready now for manufacture, so I have to actually make the tester. So I'm recycling this RP2040 tester board, but instead of having it programmed by a microcontroller, I'm going to use a Raspberry Pi, because that's the easy. I've actually written code to program an ESP32 direct from a microcontroller, and you can do it, but there's nothing as efficient. It's actually just not as efficient as using a Raspberry Pi running ESP tool, because ESP tool can do there's this compression, and instead of using the ROM bootloader, it uploads a little stub that allows you to send compressed data over, and then it uncompresses it. So it ends up being much faster. And also it does stuff like it checks, you can check is this flash already written? And then don't erase if it's already been erased. It's a lot smarter. And so, I don't mind using a Raspberry Pi here, and then having the, this has the wrong cable, but having a USB cable. You plug it in, and then of course you can upload directly with the ESP32's bootloader, and have it self-test all the pin pairs. That's what's going on underneath here. And also does a little bit of analog checking just to make sure the power and ground lines are good. But I think that's going to be the next tester I do, and hopefully we'll get the store in the store soon with the new ESP Pico Mini modules that we talked about last week. And then let's go to my computer, and I'll just show a quick. Another thing is I'm doing a lot of redesigns just because parts are unavailable, or I'm like, I might as well just do revisions that I've been meaning to do. So this is the 1.8-inch TFT, which is one of the first products we manufactured, product number 358. This is incredibly early. At the time, you could not buy TFTs on a breakout board. This was very weird. This was a screen that I think was used in either really low cost digital cameras, or really low cost keychain photo viewers. And we found a supplier that would sell us just the display, and then we like made a breakout board for it. So it's really early, and like you can even kind of tell from like it's got the old Adafruit logo, like really old Adafruit logo, and like the cell screen's a little bit like funky. And you can also tell like this was a hand soldered version that like I think we photographed, and anyways, very very long time ago. It also doesn't have the nice gold mounting holes, and it doesn't have any text here. Like it was at the time it actually made a difference if you had text only on one side. It was a little cheaper. So I was like, let's give this a little bit of a refresh. So one of the things I did this weekend is I updated it. Now has the new logo. The text is nice and wider. I put the nice plated mounting holes. I updated all our packages, like the SD card package. I've tweaked it to improve it a little bit, and then I added an EYESPI port, which I'm going to try to do to all the TFT breakouts, and that basically means, much like the the 1.69, I know for sure, having this connector, and then you can put the TFT anywhere and you can plug it in. And I'm working on making like adapters for like Raspberry Pi and Cutie Pie and Feather and stuff. And basically just instead of wiring, basically trying to have like an SPI TFT version of STEMIQT, except of course STEMIQT is easy because it's like power, ground, and 4 wires, so easy. Whereas SPI is like it's this is an 18 pin connector, and I think it's 18, and there's just like you need so many GPIO because like with e-inks you need the busy pin, the reset pin, the memory CS, the TFT CS, the ECS. Like there's a lot going on. So using the same connector that DF Robot is went with, I was like, well, you know what, I like sticking with existing standards. So adding that port to the back of all these displays will make it easy. And I just for a year there I couldn't get any displays, so I kind of like stopped doing display stuff. but I'm getting displays again. So I was like, you know what? Time to refresh. Maybe we do some of those old designs to add that port. And it'll make it easy for people to plug in our displays. And you don't have to, hand wire everything. So it's coming back. It's not over yet. But that's kind of what I've been engineering. It's a little bit of everything.
All right, let's do the great search.
Okay.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Every single week, Ladyada uses her power of engineering to help you find things on digikey.com. Ladyada, what is the Great Search of the week this week?
Okay, so this week, it's actually a lesson I learned about finding alternative parts for obsolete components, which is to always read the PCN. Even though you might think, like, oh, you take the suggestion of what the alternative component is, it's always good to read the PCN. Sometimes there's, like, little hints inside of it. So this week, one of the parts that I had to find an alternative for is this SPI FRAM chip. So let's go to the computer, and I will shut off. Okay, so SPI FRAM is, like, I think one of the underrated chip technologies out there, because every week we have somebody who's like, even like last week, somebody's like, I really need to overclock my RP2040 or my SAM51 because I'm trying to stream data from an accelerometer to an SD card, and I'm running I'm not able to stream the data. I need to be faster. And what they don't realize is that it's not frequency based. It's not how fast the processor is. What you're dealing with is you're writing data to NOR flash, like SPI flash, or on a micro SD card. And when you do that, you have to erase blocks and you have to write blocks, and that can take hundreds of milliseconds. And so, you can stream data to SD cards by, like, being really careful with, like, internal memory management, and then you buffer the data and you write the data. In fact, a lot of times when you look at how digital cameras work, they'll have a big chunk of SRAM. When you take a photo, it has to stream the data to the SRAM, and then it writes that data to the SD card. Because, again, the SD card can take hundreds of milliseconds to erase and write flash blocks. Now, you can, like, pre-erase the blocks, and there's, like, stuff you can do. But basically, if you're trying to stream data to non-volatile storage, EEPROM and flash memory have this issue of, like, block erase, block writing taking a long time. Whereas FRAM does not have this issue. FRAM is instantaneous. It basically has the speed of SRAM with the non-volatility flash memory, but it's a little bit more expensive. So, like, this is 256 kilobytes, but it has the price cost of, you get multiple times what it would be if it was NOR flash. But that's the trade-off, right? You want to have very fast data, use this. So, I do recommend people who, especially when they're doing, like, data logging in like model rockets or UAVs, anywhere where there's a really high chance of damage. Like, you want to write the data and you want to store it, but there's also a chance that things could explode, and, like, you want to be able to recover the data, or, like, power gets cut very quickly, or for extreme low power usage, because, again, you don't have to have that power spike to erase blocks or write blocks. And unlike SRAM, you don't have to provide power constantly. You can cut the power after you've written the data. So it definitely has a really cool use case. But anyways, this chip that we use is no longer available. It's obsolete. So, this is the part that we were purchasing, 4 megabit SPI, 40 megahertz, and 8 SOP. Unavailable. Again, this is chip shortage. A lot of things are going obsolete. Older lines are getting dropped. And so, you go down to substitutes, and there is a substitute, and it is in stock, and I may still use this part. But what's interesting is, well, first off, it's a little bit more expensive, and I also have to get a couple samples and make sure that not only is it pin compatible, but also that the commands used to, like, read and write data, like, there is a standard called JEDEC for SPI data, but there's often extensions to it. Not every company uses the same extensions. You know, we've dealt with this in CircuitPython. Basically, you should always look at the data, you know, get the chip after looking at the data sheet. But then I was like, you know what, before I book this order, let's look at the PCN, the product change notification from Fujitsu. And you can see this was a last time buy. We bought some at the end, but we're going to run out soon. So the chip that we're using is this one is affected. And basically, you kind of have to read what's going on. And basically, it sounds like there's a company that was doing the packaging, that they would actually take the die and they would put it into an SOIC chip and then bond the wires. And they're basically shutting down the SOP production. And so they're going to change that product, they're going to change from that specific packaging manufacturing to a different one. And what's interesting is that I've seen this before in other companies, and they usually don't change the part number. They just change the packager, and they're like, hey, whatever, sorry, it's a little bit thinner, a little bit wider, good deal. But in this case, they actually did change the part number. So what was this one is now this. Instead of JNE, it's BCE. And just for kicks, I was like, well, is that available? And it turns out that it is available to order. Now, it's not immediately available. It's going to basically be in stock in 5 months. So I'm going to probably get samples of that Cypress chip. But what's interesting is this wasn't recommended as an alternative for the chip that went obsolete. So just be aware, sometimes what's obsolete is the packaging, not the chip itself. The silicon itself is available, but it's under a different package. But you wouldn't know that unless you read the PCN. And I know these PCNs are a little bit dry sometimes, but I really do recommend going through them because sometimes they have useful information. At first I was like, is it only available in USON or TDFN? No, it's actually still SOIC. It's just from a different packaging company. So, given that, I feel pretty confident that this will be a drop-in replacement. What I can do is, order, 500 or 1,000 pieces of this. They'll show up in March, hopefully. And then meanwhile, I can also go back to that Cypress chip that was recommended. Hold on. Which was, sorry, 1 second. This one. Try this because it's available in stock, and I might have it as an alternative. Just make sure that the firmware works with both. Use this. It's a little bit more expensive, but it'll get me to March, and then in March I can get that new old, packaging style and swap back and forth. So, it's a chip shortage. We're kind of coming out of it, but there's still a little bit of rockiness on the way out. So staying flexible with different components, swapping back and forth is going to what basically gets you through the next 6 months, I think, of just dealing with minimal shortages. I mean, the lead time, 5 months is a lot, but look, it's not 2 years. I'm not seeing 99-week lead times anymore. So I'm going to pick up some of these and try this out. So this is my great search pick.
That's a great search.
Where in the world is that part I need? The great search with DigiKey.
Okay, and then
Is there any questions?
a question that came
Sure.
up. Someone said, "Oh, maybe let DigiKey know to suggest that as an alternative too."
I will, but this is something I bumped into
Live.
today.
Okay.
But yes, they watch this video, so they'll know.
Okay, if someone has a Trinket M0 connected to their computer running CircuitPython and mounting it in bootloader mode when the computer is rebooted, any ideas on how to mitigate that?
That's interesting. It shouldn't. It should boot up directly. Wonder why.
That's
Maybe
interesting.
it's
So
a
if it's in
brownout.
it mounts in bootloader mode when the computer's rebooted. You know, maybe check the BIOS of the computer and see if it has any like
Yeah.
I do things to USB devices.
I wonder if it's like trying to boot from it.
Yeah.
Maybe make sure it's your BIOS isn't set to boot from USB.
Yeah.
Because if so, it might have like some weird. Or also check your modem manager, because the
Modem manager.
Yeah, no, it's a
What?
Yeah, I'm telling you about the modem manager. The modem manager has been
This show is sponsored by US Robotics.
The PC Shopper
Yeah.
is gonna sponsor this video. Okay, the reason is that the SAMD21 chips, when you open up the serial port at 1200 baud, they kick out into the bootloader. That's a Arduinoism. Basically, you kick it at 1200. It's like, well, why would you ever open it up at 1200 baud? That must be your signal that you want me to go to the bootloader, and it goes into the bootloader. The problem is that if you're running Linux or like some other computer and you have like a really old mouse driver or modem manager, when it starts up, it's like, oh hey, that COM port, is that a mouse? And it opens it up at like 1200 baud. That might be confusing. Your computer might be confusing the CircuitPython code into booting into the bootloader. So like it's not a hardware thing. I actually think that there's something your computer's doing. The question is what? I don't know what.
Yeah. Someone says in the chat, I want to speak to the modem manager.
It's a modem manager. You laugh, but like 80% of like Linux Arduino issues are modem manager because they had it enabled until like last year, basically. And they're like, yeah, everyone's got modems. Like nobody has modems. If you're connecting them with a COM port, it's probably an ESP32.
Yeah, someone also suggested could be some weird things where it cuts the power and resupplies it in such a way that it interprets it being akin to the reset button being hit twice, assuming the Trinky does that if the power supply.
It could. I mean, you could try going through a hub.
Yeah, try
and
that.
see if that helps. It is a little bit of an unusual thing. I'm kind of guessing it's something either in the BIOS trying to boot from the drive, or if it's Linux, you have something that's opening up that COM port and messing with it.
Yeah, that's fun. You got the golden ticket. All right, them's the questions.
Okay, cool.
Oh, any word on Beano 55s?
We had some.
Yeah.
They're in stock right now.
Oh, yeah?
Yeah.
Here, click it.
Zero-
Flash out.
Yeah. We have we have them in stock,
Okay.
and we have the 085 we don't.
Okay.
However, we did ship a whole bunch to DigiKey. I should check to see if they have.
Someone says cycling the USB bus while the board is booting will make it think a reset was double tapped.
Yeah.
Maybe that could be it.
All
right, well,
I
these
do
are a
not
lot of good
have- yeah.
suggestions, everyone. Problem
No,
solved.
we don't have the. Wow, they're really on
Oh,
stock.
any word on the Ablick breakout I saw on the blog a while ago?
I have not gotten to it. It's
Yeah.
like next on my list, but I'm trying to get this ItsyBitsy out.
Okay, cool. All right.
Sorry, so the 085, we don't have the breakouts and we don't have chips. But the 085, which honestly I kind of like a little bit more than the 055, I like a little bit more than the 085, is in stock. So we
Alright.
got those chips. And they don't come from the same company, by the way. One is Hillcrest and one is something else. I can never keep track of them.
Yeah, and we'll end with a quote from the Discord. Linux COM ports are weird. It is true.
It's
That's
true.
a fact. Okay, that's the Desk of Ladyada. Thank you so much, everybody. We'll see you all during the week with all the shows.
TTYL. TTY.
Yeah,
That's my little Linux COM port joke.
that's funny. Goodbye.